Hi, I'm Dave Crow, and in this video I want to show you the differences between the newly patented heat injector and the typical heated air replacement unit.
Let's first start with an understanding of what an air replacement unit is and when one would be required. I've chosen the typical automotive refinish paint booth throughout this video to use as an example. The paint booth exhausts air to the outside, and that air needs to be replaced with fresh air. The fresh air is pushed into the process area where the contaminated air is pulled from at a volume equal to the exhaust. During the colder seasons, the fresh air needs to be heated. The traditional air replacement unit consists of these elements: the air inlet, the inlet damper, a filter section, the burner, the fresh air blower, and if it's set up with cure capabilities, there will be a discharge damper. When comparing the heat injector to the traditional air replacement unit, all these elements are similar in function, but there's a major difference in the burner sections. The traditional air replacement unit puts the burner in the fresh air stream and adds profile plates around the burner to create the optimal air-to-fuel ratio. Any change to the airflow changes this ratio, so the volume of fresh air to be used when people are in the booth is constant. The unit is either on or off. Now let's look at the heat injector. The heat injector removes the burner from the fresh air stream and utilizes a burner with a dedicated combustion air blower tuned to the optimal air-to-fuel ratio. This patented difference now allows the fresh air volumes to be adjusted without affecting harmful emissions and produces some remarkable benefits. Since the concept is so different, I've had to coin some terms that I'd like to now define. The heat injector is the system which manages the heat. It consists of the burner with the combustion air blower, the gas and flame management systems. The heat injector system manages the airflow throughout the entire system and modulates the heat produced by the heat injector to achieve the desired results of the operator. It ties the process which consumes the air to the air replacement system. With the heat injector system, the operator can reduce the air volume by as much as 70% during the times when painting isn't taking place, and any reduction in the volume of fresh air that needs to be heated produces a direct savings in gas consumption. For a typical automotive refinish booth, the airspeed could be reduced during prep, flash, and cure. Now, let's look at the gas savings that can be experienced with the heat injector as compared to the traditional heated air replacement unit on a 20-degree day, when the hood and fender is being painted. The prep time would be 25 minutes. The base coat would be applied for 10 minutes, followed by a 15-minute flash between coats. This would be repeated at least 3 times. Then the clear coat would be applied for 5 minutes with a 20-minute flash. This would be repeated before going into a 45-minute low-temperature cure at 90 degrees, followed by 2 hours at 130 degrees. In this example, the heat injector system would reduce gas consumption by 43% by simply reducing the volume of fresh air that needs to be heated. But wait, that's not all. Let's look at the electrical energy it takes to push the fresh air into the booth and compare the heat injector to the traditional air replacement unit. The heat injector removes the resistance of the burner and the profile plates, and by changing the speed of the blower motor, the resistance of the discharge damper is removed. This causes the blower motor to consume considerably less power. Let's look at the example booth. On a 20-degree day, the heat injector system could reduce the electrical energy consumed by 44%, and the reduction goes to 48% during the warmer months when the combustion blower is only required during cure. In addition to the energy savings, the burner with dedicated combustion blower produces less harmful emissions than the traditional air replacement unit, which establishes the original air-to-fuel ratio based upon paint speed. In the sample booth, that would be 12,000 cubic feet per minute. So when the speed is reduced by 50% during the curing process, the air-to-fuel ratio becomes far from optimum. On cold days, the gas flow may even exceed the operational range of the burner. On a 20-degree day in the sample booth, 52% of the gas is consumed at this less than optimal air-to-fuel ratio, and it increases to 100% during the warmer days when the burner is only used for curing. This problem with the typical air replacement unit that has curing capabilities has historically been overlooked because there is no one in the booth during the cure mode, and all the harmful emissions are simply exhausted to the outside. But we're now learning our environment can no longer tolerate this abuse. In summary, when looking at this example, the patented heat injector system reduced gas consumption by 43% and saved 44% on electrical energy with less harmful emissions. But there's more. This is what I like to call double justification. The heat injector system uses the same state-of-the-art technology that produced the energy savings to perform some advanced features. For example, heat optimization. This feature modulates airflow so the desired air temperature can be achieved even on the coldest of days. Multiple step cure. This feature allows the operator to set multiple times, temperatures, and airflows for the curing process. And then there's automatic shutdown feature, which allows the operator to choose how the system shuts down when the cure process is completed. And it has user-friendly features. We've built troubleshooting diagnostics into the programming, and the externally mounted burner, along with the modular electronics, allow the operator to easily maintain. Bottom line, the heat injector system was designed with the user in mind.
I trust you can see from this concept video that the heat injector is an energy-saving investment. We work with distributors that help you understand the benefits the system can have upon any process that requires heated air replacement. Please visit heatinjector.com to learn more about this innovative new product. And if you care to contact me directly, hit the Contact Us link on the web page. Thank you.